so to make sure that you know how to use a protractor, over here there are some lines that lines up with my 0 marker, and then this line up and down in the 90 line up with what we call our y-axis and our x-axis. So let's go ahead and line this up. Line it up, line it up, line it up. Make sure your zeros lined up. Make sure your 90 degrees perpendicular y-axis also lines up. There we go. Now I'm going to come over here, and when reading protractors, you need to be careful. Are you reading the top numbers or the bottom numbers? Either way, it's completely a-okay. But I'm going to read the top numbers. The top number says 123. Is that, if from 0 up, 123 degrees? No, because at this mark or this location, it's 90 degrees. So guess what? 120 degrees subtract 180. This is 180 or a half a circle, right? Because I'm reading the outside numbers. Or you can read the inside numbers. Either way, I just like reading the outside numbers because those little lines are outside. So 100 and, oops, I got off. There we go. 180 degrees. Take away, oh, there it is. Oops. Oops, I was wrong. 122, 122. So 180, oops, turn on. 180, take away 122 equals, that theta is 58 degrees. In red, I should have said that, but forgive me, I forgot. But go ahead and do it with your pencil or pen. Right here, this is 58 degrees, that theta. Okay? What is yours? What is your theta? Write yours in. I wrote mine in. I went ahead, I went 122, take away 180, I got 58 degrees. That's my theta. This theta is 58 degrees. Let's do it again. Okay, you've got your protractor. I do want you to use the red pen. It's going to be part of the lab. I'll go grab red pens. I forgot to break those out today. I broke them out earlier on Tuesday. Yes, sir. We will finish this lab paper up. Shall we be ready? Because on the lab it says in red. I'll put the box of red pens over here by Miss Shelby. Yes, sir. Okay, so one more time. I line up my 90 degrees or my y-axis with my 90 degrees, and over here where it's crisscrossed right there, that's my x-axis, my y-axis. Once I line that up, and that needs, and then you got to hold it so it doesn't move. There we go. There we go. Then, oops, 121, 122. To find this theta right here, well, this theta is not 122 degrees. This theta right here. Because if this is 0 and that is 90, it's less than 90 degrees. Less than 90 degrees. And so what I did was I got the 122, 123 right here and subtracted from this right here line is 180. So I got 180, take away 122, and that's where I got 58 degrees. Okay? We're going to do this on our notes in a moment, so we can figure out and be prepped and ready for homework. Okay, let's do it again. Line up your X and Y axis with the 0 and the 90. Now, I'm going to use the top numbers. I got 122, and this one right here is in between, not a problem. That's 60, that's 70, that's 65, 66 and a half. So 66 and a half, or 66.5, subtract 122. Again, I don't care about negatives. I got 55.5 degrees. So there we go. Look at this. From green line to green line, that is 55.5 degrees. From green line to green line. Do it again. This is a lab. Not bad. That's good. Let's do this one again. Let's do rad number 3. Green line to green line. What is that theta? And then do from green line to 180. So let's finish it off. We did it in the other classes. We just didn't do it in here. So go ahead, do those last couple of bits that you've got left over. 66 and 8. 8, take away 66, I got 58. Dang it. Okay, let's do it again. 68. Oh, that's 8 degrees. Green line to green line, green line to green line, green line to the pencil line. So, I got rad number 1, rad number 2, rad number 3, extra piece, or 0.14. Ooh, yeah, teacher, you try to teach me, oh, pi is 3.14, but you never explained to me what 3.14 is. You know what they've been lying to you also? Santa lives in the North Pole. You're a darn liar. Actually, it's really the South Pole. That's second semester. I am telling you, I'm here, my goal is to teach you right. These teachers have been teaching you wrong this whole time. Santa actually lives in the South Pole. There you go. That's, yep. So what did I got? What did I got? I got 58. I got 55.5. I got 58. I got 8. What should those? 180. Should be 180. If I'm off, then my math ain't mathing. All right, we're going to start off with Shelby, and we're going to then go to Jordan, and then we're going to come back over here to Robert. I need your numbers. 1, 2, 3, and the extra. All righty? Shelby, you ready?
Oh, mine were the same.
The same exact.
Mine were two.
Cheater.
Mine were 2.
No. There's, you got literally, okay, no, call it out. I don't even trust you. But go.
It's 58.
Do it again.
55.5.
Oh, I feel like I'm going to throw up.
And then 58 again. And 8.
Never mind, I didn't get the same cheater. I just got the same between rad number 1 and 2.
So you're not a cheater. Jordan, what'd you get?
56 degrees.
56 degrees.
56
56
degrees.
degrees.
56 degrees.
Whoa.
And then 12.
Give it to me.
59. 56. 56. 59.
Give it to me.
Application.
Who else?
55, 55, 55, and 11.5.
Give me what you got, Robert.
51, 56, 55.
Okay. All right. That's, you write your last one and I'm gonna start talking. Here we go. What we need to talk about real quick is that I got 58, 55.5, 58, and then 8. Shelby got, not because she's a cheater, but because we are using the same exact plate size. And she got 58, 55.5, and 58, and 58. But this person, 56, 56, 56, what did I say the key word was earlier this week? Perfection. Did Jordan use the same exact string? And when we did it, Shelby, did we like use a different string in between? Because something's off. Because we got over here 56, 56, 56. As in, Jordan used the same string on rad 1, rad 2, and rad 3. To be honest, all of us should have got the same exact number for 1, 2, and 3. No worries. Me and Shelby are pretty awesome at 58, 58. We're pretty awesome. Wait a minute. 56, 56? Pretty awesome. 55, 55, pretty 55. Pretty flippin' perfect too. You got a competitor now. He came in next 8 weeks, 9 weeks. You got somebody that right there now to compete with. Robert did pretty good. 56 and 55. Pretty darn close to each other. So looking at our data, which should make sense, let's stop and think about it. We cut the string, snip. We wrapped it around the circumference counterclockwise 3 times, same string, same plate. To be honest, every one of us in the classroom should have got the same exact number. But why are we off? We're human. Give it to me.
So would a perfect one be like 57?
Actually, a perfect one, it says in our notes, I could have sworn it says 56.5 is perfection or something like that. To be honest, there's an actual number.
Wouldn't it be like 180 divided by 5?
180 divided by pi?
Wouldn't that be a
What's
perfect
180 divided by pi?
57.29.
57.29? Yep. So, not bad. Does that make sense though? Because every single one of your rads, rad 1, 2, and 3, should have been the same size. We are human and we're not perfect, even though we were trying to hit perfection earlier this week. So, tomorrow I'm going to have the lab paper for you printed out, and I'm going to go over what you need to do, okay? You don't have to do it until next week in class. I'll give you lab time in class because you need a protractor, and I'm not expecting everybody to go buy a protractor, if that makes sense, okay? So we might need some in-class time for this. So we now know how to utilize a protractor, and we did 1, 2, 3.1 for rads, and we figured out what we got. Here's the one thing for the lab. What I'm going to do is I'm going to grade your paper plate. I'm not going to grade every single one of these rads. I'm going to pick one rad. I'm going to circle it on your lab paper. I'm going to use my protractor, and I'm going to use my protractor, and I'm going to grade it. If I got 55.5, then you should have got 56.5, 55.5, or 54.5. I will give you 1 degree over or 1 degree under. So perfection, taking your time is the key, okay? If not, it's wrong. Does that make sense? So perfection. All right, yes, sir.
How did you line up with protractor? You didn't line up with the 90?
I did. I lined it up. I lined up, this is my y-axis with my 90 and this right here. See this little cross hair right here? That is also lines up with your y-axis. And over here, this line, and this horizontal line lines up with your x-axis. We're going to use the protractor again in just a moment. Let me move this out our way. So here are our notes. This part that I skipped over, I'm just going to write it in, but literally it's just right here giving you the directions. Direction number 1, when you're drawing a free body diagram, you only draw that one object. You do not draw extras like grass or butterflies. I don't give a care about those. Number 2, when you draw your free body diagram, you draw it in the orientation that it's in. Is it flat? Is it at an angle? How is it? Okay? Then you're going to write in your forces like this. If they give you a magnitude amount, then you're also going to add the magnitude amount like over here. We have the magnitude amount. Okay? So I'm going to write those notes in. I haven't scanned anything onto D2L just yet because we just started Unit 3. My goal was to try to wait till Friday to do that. Okay? So that way I'll have a whole week. And I will post video notes also. Okay? Now let's go ahead and let's turn this over here because we're going to finish this, which is going to be on quiz number 1 next week on Tuesday. Again, this is going to be correlation because remember, we did SOHCAHTOA and Pythagorean on the last unit. So we should really knock this quiz, should be really good. Seriously. Okay? We haven't got into new stuff yet. This is still old stuff. We're just shaking it up a little bit. So we did this practice problem. We did this practice problem. Now, before I go further, I said this at 8 a.m. When you are finding the weight force of an object, meaning, oh, I've got this little thing, bucket of pens or markers, and I'm going to sit it on the table. What is the weight force of this? Well, F equals ma, or Newton's second law, is that equation. And A is gravity. But if I say, oh, wait a minute, what's the acceleration of this when I throw it? A is not going to be gravity because it's in motion. And I want to find the acceleration regarding its velocity. Does that make sense? Now let's read question number 2, which is kind of written screwed up. So let me read it to you. It says here, Roberto and Laura are sitting across from each other at a table. And it says that Laura slides this book that has a mass of 2.2 towards Roberto. If the net external force, F, acting on this book is 2.6 newtons to the right, period, what is the book's acceleration? Question mark A. I'm not going to give gravity because the book is doing what? Moving. Okay? So I'm going to put this right here. She slides the book. And I'm going to write myself a note. You don't have to. I am. Because the book is moving, A is not 9.81 gravity. Does that make sense? Because I have students who answer this on the quiz and they legit write 9.81. Well, I'm not looking for the gravitational force and using A as 9.81. Okay, but Miss Munson, did you say in Unit 2, A equals VF minus VI over T? I did, but they didn't give me a VI, a VF, or a T. And so they didn't even give me a distance on how far the book moved. So for this situation, I am going to use Newton's second law of F equals ma equation. I am. They gave me the force of 2.6. They even told me, on that quiz next week on Tuesday, if they give it to you in pounds, you need to convert it into kilograms. But they gave me kilograms of 2.2. Multiply it by A. So now, algebraically, we can solve. Divide by 2.2, cancel, divide by 2.2. A equals blah, blah, blah. 1.18, that works. 1.18 meters per second square. Okay? So I don't want anybody to get confused next week on Tuesday for this kind of quiz question because it's actually moving in motion. Okay, so let's turn the page when you're ready. And we're going to do a little quick review over circles, meaning what we talked about earlier this week and what you already know from geometry class. Okay, I don't know, what's that, 10th grade-ish maybe? I don't know, 9th grade, 10th grade? So let's talk about a little bit of vocab and some stuff that you've already covered before you even came to this class. Okay, first thing is over here, it says, suppose that you're driving your car, but you have your steering wheel turned in such a manner that your car is following a perfect circle. You're doing donuts in your car. How about that? Okay, with a constant radius. And suppose that you have your speedometer set to exactly at a constant speed of 10 miles per hour because you're in a car, miles per hour. This type of situation occurring would be called uniform circular motion. Uniform circular motion is considered to be the motion of an object in a circle, because it's traveling in a circle, with a constant speed. But here's really the question. Are you accelerating? You're making donuts in the parking lot. Oh, there's this mean goose that tried to attack you, and you saw him out in the parking lot. And you said, how about this goose? You start doing donuts around him in the parking lot. He's, you know, right? Isn't that kind of the sound that those goose, those things are mean. And now the goose is kind of freaking out because you're outside of the parking lot doing donuts, but yet you got the speedometer. You're like, go ahead, get out, walk. I'm not trying to purposely hit you, but if you walk and try to commit suicide in front of my car, then that's on you, duck. You know what I mean? Kind of thing. And so you're doing perfect circles. And your speedometer, it says 10 miles per hour because you're going really slow. You know, you're trying to scare the duck. You're trying to show the duck who's boss. Don't try to attack me again. Are you accelerating? Yes or no? No. You are. You are accelerating. Why? You're changing what? You're changing directions. At every single moment as you're moving and doing those donuts in your car, your steering wheel has to continue. You keep your steering wheel turned so you can continue to make a perfect circle. So if your steering wheel is turned the whole time, you are accelerating even though you are moving at a constant speed. I'm going to go ahead and write myself a little note. Yes, you are accelerating because I agree. You are constantly changing directions. You have that steering wheel turned at a constant, doing a perfect donut around that duck, showing that duck who's boss. Okay, so circumference. We've got a little bit of vocab that you should already know. The circumference of the circle is going to be the perimeter perimeter of a circle. I'm going to put in parentheses outside. And the radian is what we talked about earlier this week. We got this string that was the radius length string, but we wrapped around the outside of the circumference of the circle. So the radian is the length of the radius on the circumference of a circle. And it's wrapped around the outside. We call it a piece of the pie, a piece of the pizza. That little slice right here is a rad or a radian, okay? Okay, so now here's where we're going to tie in our geometry that you learned in math class into pre-cal, okay? And we kind of go back and forth in physics between your pre-cal brain and your geometry brain, okay? So we need to be able to do that. How many quarters are in $1? 4. How many quarters are in $2? 8. How many dimes are in $1? 10. How many dimes are in $2? 20. See how you can go back and convert back and forth pretty easy cheesy? That's what we need to be able to do, but we need to do that between geometry / pre-cal so we can do it and use that in physics. All right, here we go. First question, it says, how many times will a radian fit around 180 degrees? 1, 2, 3. Go ahead and write this in. 0.14 rad. How many times? 3.14 rad. What do we call that number since you've been little? Pi. You call that pi. How many times will a radian fit around, 6.28 rad. What is the formula for the circumference of a circle? Not 2 pi r. 2 pi r. 2 pi r. But wait a minute. In geometry math class, whoever your geometry teacher was, this r, that lowercase r, is the radius. For us in physics, it's the rad, which is the same thing as the radius wrapped around the circumference of the circle, okay? So in geometry, it's a radius. In physics, it's a rad, which is the distance of the radius wrapped around the circumference of a circle, okay? So it says over here, how does this compare to the number of times the radian will fit around the circumference? Those two are the same. They're the same. They're absolutely the same. You have been doing a little bit of pre-cal and geometry this whole time. So I'm about to throw in a new word. Our new word is pi radians. Pi rads. We call it pi rads in physics. How many pi rads are in one rotation around a circle? Okay, well, this is, let me say it this way. This is 1 pi rad. So 2 pi rads is a full circle. 2 pi rads. 2 pi rads. Which is the same as that equation you've been using. Okay, how many, wait a minute, not pi rads, but how many radians are in one complete rotation around a circle? 6.28 rads. How many pi rads? I guess I should have do this. Go ahead and scratch it out. I don't want that to be confusing. How many pi rads are in 2 rotations? Not 1 circle, but 2 circle. 4. 4 pi rads, or 4. Okay, do you see how many quarters are in $1? 4. How many quarters are in $2? 8. Do you see how your brain is starting to click on this now? How many radians are in 2 complete circles? 12.56 radians. Okay. If 2 pi rads fit in 1 circle, 1 pi rad, let me go ahead and do this. This part of the circle is going to be 1 pi rad. This part of the circle is another 1 pi rad. So a full circle has 2 pi rads. But what if you do 6 rotations or 6 circles? How many pi rads? 12. Easy cheesy, Miss Munson. Good. Good. 12. Okay, how many rads? Okay, we're not talking about pi rads no more. We're talking about the pieces of the pie, the slices. How many rads are in 4 pi rads? How many rads? What was it again? Thank you, 12.56. There you go. Absolutely. You just converted geometry to pre-cal. That's what we just got there doing. Now in pre-cal though, they kind of look at a circle, or for those of us who maybe are in pre-cal right now, or will be in pre-cal, they look at this, what we call a unit circle. I just think personally it's really confusing. And so I try to, that's why I do my circle with all my students first, to try to break it down a little bit. Here's where we're trying to get to. We're trying to get to this business. But look at this, the 0 degrees all the way to 180 degrees, or we call that 1 pi. Or we go to 360 degrees, or we call it 2 pi, or 2 pi rad in physics. Okay? So this is a half of a pi. Pi over 2 is the same thing as a half a pi. This is 1 pi. This is, yes, 270 degrees, but it's also called in pre-cal 3 pi 2. 3 pi over 2, which is going to be 3/4. Thank you so much. 3/4. What do you call it? Fractions. I can't speak fractions. Okay, but we're going to do this equation. This equation is, these 2 equations are going to be on your quiz next week. I'm going to pause. Let me get the formula chart because I don't want anybody to freak out on me. For those of us who are from Dickinson High School, Mr. Glebe is an amazing physics teacher, and over at Dickinson High School, he has you memorize all your equations. For those of us who are going to take pre-cal here in College of the Mainland, again, pre-cal teachers are amazing. There are some really awesome pre-cal teachers, but again, they make you memorize these 2 equations. I feel like you have a lot of stuff to keep up with. So I added those equations. Look, it's over here. You have to turn your, sorry. Those 2 equations are considered to be a memorized equation, seriously. But I feel like you have a lot to memorize, so I literally added those equations on the side of the formula chart. There it is. They're right here on the side for you. So I just wanted to go over that. I don't want you to freak out. Here they are. If you want to go from degrees to radians, you're going to get that number and multiply it by pi over 180. If you want to convert radians or rads to degrees, you're going to get that number and you're going to multiply it by 180 over pi. Now I'm going to pause for a moment. What do you mean, Miss Munson? Well, let's look at this pie chart or this circle. You remember how we did 0 degrees? And then I said, oh, at the top is 90 degrees. And then we did the radians, or the rad 1 and rad 2. If I'm going to ask you, how many rads are in 90 degrees? This is 90 degrees. How many rads? 1 and a little extra. 1.6 is she? Because this is 2 rads. This is 90 degrees. So about 1 and a little extra, 1.6, 1.54 rads are in 90 degrees. Okay, isn't 45 degrees somewhere's about right here?
Yeah.
Okay, so how many rads are in 45 degrees? Not a full rad, so like 0.68 of a rad is 45 degrees. So we're converting degrees into rads and rads into degrees now. Okay, wait a minute. 360 degrees, which is a full circle, is 6.28 rads. Ah, okay. So now let's do that. Let's say you've got 225 degrees and you want to go to rads. So you're going to get 225. You're going to multiply it by pi over 180. Got your calculator out or your cell phone, because cell phones, or you could just say 3.14. But go ahead and when you do that math, double check me, but I did this also already, and I got 3.9 rads. 3.9 rad. 225 degrees. If this is 180 and this is 270, 225 is about right here. So, 225 is about right here. So 1, 2, 3, and I didn't get to complete a 4th rad, but 3.9, that's almost 4 rads. Okay, let's do it again. But instead, this is a rad right here. Same thing that you use in pre-cal. And you want to convert it into degrees, as in degrees of a circle. Go ahead, 5 pi over 9, multiply it by 180 over pi. Do you see how my pi's cancel out? My pi's cancel out. So 5 times 180 divided by 9, you do your math, but I got, there you go, degrees. That's what I got, 100 degrees. We are almost done. We are going to turn and just do the next page. Okay, we're not doing all of it, we're doing most of it. Okay, so when you're ready, it says use your protractor. Oh, get your protractor out. Here it is. Turn the page and get your protractor out. This looks like homework number 2. The last 2 questions on homework number 2 looks like this. And guess what? You're going to have some of these on your quiz next week. It's going to say degrees and radians. And then you're going to have some questions like this at the bottom on your quiz next week. Okay, so let's go ahead and let's see. When I'm going to do a worksheet like this or a question like this, I like to get me some extra paper on the side. For an example, let's look at number 4. I'm going to do number 4 first. What I'm going to do, oops, careful, is do you see that little line? If I put my protractor, do you see how that little line that's shooting off is not even over here? It's too short. So I use my protractor and I come over here and I'm going to extend that line. Not only that, but my protractor is too big to line up with my X and Y axis. So I'm going to come over here and I'm going to extend the X axis and the Y axis just a little bit, so that way, look at that, that's pretty perfect. And I'm going to extend them, so that way when I go to line up, I can line up my protractor nice and pretty. So I extended the X and Y axis. I extended that arrow. Do you not agree? Hopefully you do agree. We always start at 0 degrees on the right side, and we rotate counterclockwise up. What is that top line? 90. What's the next line horizontally? 180. So look at the little arrow. It started over here, and it rotated from here all the way to right here, and that's where it ended at. So if you had to guesstimate, isn't it larger than 90 but less than 180? What, 120 degrees is she? 130 degrees? Let's go ahead and do that. Get your protractor, line it up, line up the 90 on the x-axis, line up the x and the y. I got 90, 155, 156 degrees. Hopefully that 156 degrees right there. I use the bottom numbers. 156 degrees. I definitely know it's bigger than 90 and less than 180. Right there. 156 degrees. Convert it to rads. Well, my equation on the previous page says to go from degrees to rads, I'm going to multiply by pi over 180. So 156 multiply it by pi over 180 equals your degrees. Easy cheesy. We got 2.74 rad. Let's do number 1. Number 1 is easy. You don't even need the protractor, do you? Because, yeah, 90 degrees. It ended up right there at the 90. And my radian, let's figure that out. 90 times pi over 180 equals, come up with your answer.
1.57.
There you go. That's what I got too earlier today. I'm promising you, those are questions that you're going to see on the quiz next week. And these questions are going to be on homework number 2 that's due next week on Tuesday. So practice it. Let's go ahead and let's scroll to the bottom, and then we are officially done. Okay, it says here, if for some reason you have a car that makes a perfect circle 3 times, 1, 2, 3 perfect circles, how many rads did it transverse? Well, if one circle is 6.28, and the second circle, there you go. 0.85. There you go. Easy cheesy. You're ready for this next quiz. Let's do it again. When you're riding a Ferris wheel and your car that you're on makes 2.7 complete turns. 2.7 turns. How many rads did it transverse? How do you do that? What did you multiply this 2.7 times what?
I multiplied it by 2 and then by pi.
There you go. You multiply this by 2 pi. I'm going to pause for a moment and I'm going to turn to the previous page. Because earlier I said a key word, and I don't know, for some of us who might be like I'm unsure how she got that. Did you listen to me earlier when I said over here? How many radians will fit around 360 degrees? And you told me 6.28 rads, Miss Munson. I go, cool. And then I said, what's the formula for calculating the circumference? And someone said 2 pi r. And what did I tell you this R? In geometry class, it's called a radius. But in physics, we call it a radian, which is the same thing as this and this are the same thing. So let's look. 2 pi r, 2 pi radian turn r. That's my 2 pi r. So that way I can get blank rads. Okay, now let's reverse it. If you're fishing and it's going to take you 408.2 rads, we're using this, but we're going opposite. Say it again. So divide. There you go. 408.2 rads. I agree with Carlos 1,000%. You're going to divide by what? 2 pi. Rotations. That's how many times you're going to have to turn that fishing reel so you can get that fish. Exactly, because 2 pi r in physics is 2 pi radians or 2 pi rads. But in geometry, you call it 2 pi radians. We call it 2 pi rads. Oh, radius. I'm sorry. In geometry, 2 pi radius, 2 pi radian, which is the same thing. We are so done. You have a great day.